Hello, this is Manuel Gadi. This is a quick video explaining the individual programming exercise, the mechanics of the difficult part. Where it explains that every choice of the player is influenced by his previous choice. Therefore, we're going to count that. So the mechanic is simple. We have to count the number of times the human player chooses 0, given that in the previous beat his choice was 0, and then the 0 to 1. So this is the previous one, this is the current, previous, current, previous, current, previous, and current. So let's have the choice of the player, and let's start all the variables with 0. Whatever happens here, we don't have a previous choice, so you'll see that the first round, the computer will always choose as random, so it's going to use the linear congruence method. And let's suppose in this time that the choice of the player was 1. So the first move we need to do is the computer choice. So computer has to choose first, because otherwise it's going to be cheating. So we're going to be seeing what happened in the previous round. So the previous round was 1, and then here we have the counts. It's all 0, but in any case we have 1 here. So you can see in the documentation what happens in the case of previous choice of the player. The documentation says, well, you have to choose this guy over this guy. Choose 1 if 1 1 is bigger. If the player keeps choosing 1, you pick 1. If the player has just changed from 1 to 0, or from 1 to 0, you pick 0. And then it's actually the amount of times it was picked anyways. But if it's equal, you do a random choice again. That's with the linear congruence. And in our case, well, we picked 1, but we can see here that the previous one is 0, 1. So this is the previous, and this is the previous. All counts are equal to 0. So in the second round, you also gonna have a linear congruence choice, a random choice. So let's suppose that the player picks 1 again. So we don't have a previous 0 followed by a 0. No, we don't. So this remains 0. We don't have a previous 1 that turned to be a 0. So this is, again, it's a 0. We don't have a previous equals to 0. So this is a 0. And we do have a previous that continue to be 1. So we add 1 here. So what happens in this case? Well, the previous choice of the computer was 1. So the rule says if the previous is 1, I have to check whether the 1 1 is bigger or smaller than the 0 1. And I actually pick the big one here. You can see if it's 1 1 bigger than 0 1, I pick 1. If it is the 0 1 that is bigger, I pick 0. Otherwise, if it is the same, we pick randomly. So let's see what happens here. The 1 1 with the 0 1. Well, the 1 1 has a count of 1 right now, and the 0 1 has a count of 0. So what's going to be the computer choice? The computer choice will be 1, because that's what it says. It picks the one with a bigger number here. It is going to pick not this number 1 here, but it's going to pick 1 because this is it's going to pick what is here actually at the very end, at this position here. Good. So this is going to pick 1. Let's suppose now the player carries on with the 1s. And so again, this is a 0 because I don't have a 0 0. I don't have this. This is going to go to 0. And this is going to go to number 2. And obviously, this is a number 1 again. So I'm going to get the greater number between this and this one. And this is 2 now. This is 0. This is going to, computer is going to continue to say 1. That's the choice of the computer. Remember that computer chooses first. So in the round 4, computer will choose 1. Let's say that the player became upset and now he chooses 0 to try to win. Oh, so how do we do the counting then? So it's a 0 follow with a previous 1. So that's here where we have to sum. This is a current 0, 1, sorry, a current 0 with a previous 1. So we have to add in here. All the rest carry on the same. So this is a 0, this is a 0, and this is a 2 because I'm not adding here. I've just added here because I have a 0 that follows a 1. So it is a 0 now. What's going to be the computer choice? Well, it's a 0. I'm going to get the couple here that have zeros. Oh my gosh, they are zeros. So computer will do a linear congruence method in this case. Good. What happens next? What comes with the guy comes here, the player comes and says 0 again. So we have now a 0 followed by a 0, and that means that we're going to add 1 in this one, and the rest will carry on 0, or just carry on the same. And now I have a 0 choice, that means between this and these guys, and this one is the one that is leading. So the computer will choose as his next move as 0. Now the game is becoming complicated for the player because computer has some knowledge about the player already. So if the player chooses 1 here, where do we have to add? We have to add to the 1, 0, because this is the current, this is the previous. So where is the 1, 0? Here it is. So this is the one that is going to be adding 1. This is going to be 0. This remains the same as a 1. And this remains the same as a 2. And then the game goes on because the computer can choose again. So this is a current 1. So I have to choose the greatest between those two, the ones that end with 1. So which one is the greatest? The 2. So the computer will pick 1. So again, the computer thinks the guy is going to repeat. Every time he picks a number 1, he's going to repeat. And by the way, that's what happens, because the guy just too big 2 times. So the computer is actually doing the statistics, how many times you actually repeat it, or you go to the other direction between the 0 and 1. So this is the actual mechanic of the game. And what you need to do, well, you have like 6 variables here. One is the computer choice that must be done first in every round. And then you pick the choice of the computer, the player picks his choice. And then, well, you check it if either they are the same or different to calculate who is winning. But then you do a calculation, or you're doing the counting. And obviously you don't have these. As you are on the 6th round, the numbers you have is 1, 0, 1, 0, 1, 2. All that happened in the past, you don't have it anymore, because you only have the current state or the current round state on your code. So your code should be keeping only the last move of the player, the last move of the computer, and these calculated variables throw 0, 0, 0, 1, 1, 0, and 1, 1. So I hope this video helps you with the mechanics of the game, and so you can implement the difficult one. So sometimes the difficult one will require you to call the linear congruence as a random choice because of but it will depend. Not a single game will be the same, because the game will depend actually on the choices of the player, as you can see.